Hello, everyone, and welcome to Precalculus. This is section 6.2 on the law of cosines. In section 6.1, we learned about the law of sines, which works for angle, angle, side angle, and side angle, which remember is the ambiguous case. The law of cosines is going to work if you're given 3 sides or if you're given 2 sides and the included angle. Although I have to tell you, I don't really worry about trying to learn all these different possible combinations. I just always try the law of sines first because it's easier. And if I don't have a matched pair, meaning I don't have an angle and a side combination, which is all you need to make law of sines work, then I switch to the law of cosines. Because as you can see, its formula is a lot more complicated. So this is just one form of the formula. Another one would be if you knew angle B, then you would start off with B squared is equal to A squared plus C squared minus 2AC cosine of B. You might want to try and write that third one on your own. It is C squared is equal to A squared plus B squared minus 2AB cosine of C. So now you have all 3 different versions of it depending on which angle that you're given. So let's do an example. Find the length of side C given the triangle angle C is equal to 60. So here's angle C. A is 10 and B is 14. It doesn't really matter which one I put where, but since B is longer, I'm going to put B there because A is shorter, just to keep it somewhat correct. So I do have my side, angle, side, meaning I don't have a matched pair. So there's no way for me to get that third side. You cannot use the Pythagorean theorem because it's not a right triangle. So I have to use law of cosines. Easy enough. I know angle C, so I'm going to use this third one. So C squared is equal to A squared plus B squared minus 2 times A times B times cosine of C. So you can go ahead and plug that into your calculator and then take the square root, because this is actually going to give you C squared. So you're actually going to have to take the square root of your answer, and it should come out to be 12.5. So it's not a hard formula to use, but it is a long formula to memorize, so make sure it's in your appendix. Number 2, solve triangle ABC. So this one is a little bit harder. Now I'm being given 8, 14, and 19, definitely not drawn to scale. So this is going to be B, C, and A. In the situation where you are finding the angle, always find the largest angle first. And the way you know which one is the largest is if this is the largest side, then it must correspond with the largest angle. So I am going to find angle B. So I'm going to use the formula B squared is equal to A squared plus C squared minus 2AC cosine of B. Now, some people will rearrange this formula first and have it written down more than one way in their appendix, and that's fine. But I would just plug it in now, and only the less things I have to keep in my head, the better. A squared is 8 squared, C squared is 14 squared minus 2 times A times C, and then cosine of B. So I do want to give you just one quick caution. The biggest mistake that I see is putting all these together. Do not combine these. That is the most common mistake, that people do all this math and then they just put it next to the cosine B. But that's not at all how it is. it's going to be 19 squared, which is 361. And then this is going to be 8 squared plus 14 squared, which is 260, minus 16 times 14, which is 224 cosine of b. So I can see how it's very tempting to combine those, but they don't go together. Instead, you're going to do the 361 minus the 260, and then you're going to divide by that 224. Divided by 224, negative 224, gives me negative 0.45089. I don't actually expect you to have all those numbers written out, but this is your most recent answer on your calculator. So I'm going to do inverse cosine of answer. Make sure your calculator is in degrees, and that will give me 116.8 degrees. So now that I have this one, I don't have to use law of cosines again. Now I can finish the problem with law of sines. So, because I have a matched pair. So 19 is to sine of 116.8 is equal to, doesn't matter which one we do next, let's just do A, 8 over sine of A. And after I did it, I realized my sine of A is on the bottom. So remember, if that bothers you, you are more than welcome to flip the law of sines upside down and do it that way. So when you do that, you're going to have to use that inverse sign again, just like we did here. Make sure you use the answer to get the full number, and you'll find that A is equal to 22.1. Once you have two of the three angles, you could use law of sines again, or you could just subtract from 180. And angle C is going to come out to be 41.1 degrees. Number 3, this is one that now you can try this one on your own. I'll write down the answers for you. Angle A should come out to be 55.154. Angle B should come out to be 48.101. And angle C should come out to be 76.745. I only wrote out the whole number so that you can check your rounding. You're welcome to just round to the nearest tenth, though. But of course, I will do it for you. Again, I always find the largest angle first. It prevents the ambiguous case to do it this way. So since I'm going to start with C, I'm going to use C squared is equal to A squared plus B squared minus 2AB cosine of C, which is going to be 51 squared is equal to 43 squared plus 39 squared minus 2 times 43 times 39 cosine of C. So if you think you're going to make the mistake of combining these, do not combine. I have seen some kids rearrange this to be C squared minus A squared minus B squared all over negative 2AB, and then they do inverse cosine of that. And you are more than welcome to do that entire thing right like that. When you do, you will get 76.745 degrees. Once you have one of the three angles, then you can use the law of sines because now you have a matched pair. You have C and angle C. So it doesn't matter which one you find next. Let's just do B. So sine of B is 239 as sine of 76.745 And I think that's why I left the 3 decimal places out, because I'm using it to find other answers. If I round this one to the nearest tenth, then probably this one won't round correctly. So it's always good to go out a few extra decimal places. Over 51. Again, you're going to want to multiply both sides by 39. But when you do that, you're going to get an answer on your calculator. So then you can just do inverse sine of answer. And that should give you the 48.101. And then you can find A by subtracting from 160. Angle A, or 160, 180 minus B minus C. So let's put that into a word problem. A field is triangular in shape with sides 473, 512, and 734. What is the measure of the angle between the sides measuring 512 and 734? So it doesn't matter which one is A or B and C. It just matters that you understand which one relates to which one. So the angle between the 512 and the 734 is this one. So let's call this A. It doesn't matter, but you got to give it something to make sure that you can use the formula correctly. That's the angle that I'm trying to get. So you could call this B, you could call this C. And again, now you could use this alternative formula since you're jumping straight to trying to find the angle, but you would have to have it rewritten a different way. This is not going to be C squared minus B squared. If you want to do that, then you would have to start with, or I guess I could have made that C, and that would have fixed the problem. And then I could use that formula. But the point is, your job is not to necessarily have A, B, and C lined up. It's just to make sure that you understand how the formula works. All right, I'm going to be looking for this math somehow set up on your paper, but I will tell you the answer is 39.834 degrees. So I'm going to write show me, whichever way you decided to do it. Number 5. So this one's just a little bit trickier. It says that the pitcher's mound on a women's softball field is 43 feet from home plate, and the distance between the bases is 60 feet. So I'm just actually going to use a little drawing tool here to help me. Otherwise, it would be a terrible picture. So there we go. We got our baseball diamond, and here's the pitcher's mound. This is 45 feet away. 43 feet away. And the distance between the bases is 60 feet. And they want to know the distance from the pitcher's mound to first base. So we'll call that A. So the thing that they don't tell you in this problem, but hopefully you can see by looking at it, is the pitcher's mound, while it's not halfway between home and second, it is going to cut this angle in half. So this 90-degree angle is going to be cut in half, and this will be a 45-degree angle. And that's what's not stated in the problem, but is needed to do to get the answer. So now I have a perfect setup for law of cosines. Remember, use law of sines whenever you can, but I don't have a matched pair. Law of sines always means I need an angle and the corresponding side. So I have to use law of cosines, no problem. I called that A, so I could use A squared is equal to B squared plus C squared minus 2BC cosine of A. So A squared is going to be equal to, notice I didn't actually label them, just the other two sides. 43 squared plus 60 squared minus 2 times 43 times 60 times cosine of 45 degrees. So once you get this answer on your calculator, again, I'm just always trying to show you calculator shortcuts, you can do either answer, just it'll come up on its own, to the 0.5, because remember, square root of something is the same as something to the 1/2, which means it's the same as something to the 0.5. Little trick there. That's what I usually do. It's faster than doing square root and then typing in the answer button. So a couple different choices there, but no matter how you do it, you should get an answer of 42.43 feet. All right, moving on to another area. You might remember that we did some area yesterday. Well, none of the formulas that we used yesterday worked if you had just all sides. So Heron came up with a formula for that. Area is equal to the square root of s times s minus a times s minus b times s minus c, where the quantity s is the semi-perimeter. So hopefully you know that a perimeter is the distance all the way around this plus this plus this. So the semi-perimeter is the three sides added together, but then divided in half. It's not an average. Be careful that you don't divide by 3. It's divided by 2. So this is the value for S. So let's go ahead and use that. This is definitely one where if you don't know this formula, you're going to be doing a lot of trig to find base and height so that you can do these problems. Find the area of a triangle having the lengths. So I'm going to put my A here, 43, my B here, 53, and I chose this one for C because it does look the longest on my picture. And just to make you appreciate Heron for a minute, if you did area is 1/2 base times height, you would have to find this height. Well, in order to find this, because the base you'd have would be 72, but in order to find this height, you would have to first find this angle using law of cosines, and then you'd have to find the height using trig. That is definitely more work than you want to do. So awesome Heron came up with this formula. All you have to do is find the semi-perimeter. So if you do A plus B plus C, and then you divide that by 2, you will get 84. Now that I know the semi-perimeter, I can just plug it right in here. 84 times 84 minus 53 times 84 minus 43, the order doesn't matter, and then 84 minus 72. There you go. That's Heron's formula. All right. You've got a couple more problems now to try on your own. I am going to go ahead and give you the answers to them in case you decide that you want to work them out on your own and not watch the rest of this video. That would be great. And the last one, 202.078 feet. But of course, as usual, I am going to do them for you. All right, number 10. Find the length of the altitude from A to BC. Well, when people think altitude, they usually think about dropping it down like this. So even though we normally often put A down here in this corner, we're going to put it up top because it does specifically say the altitude from A to side BC. So it'll help you probably draw it if you put the A on the top. So A is 24, B is 14, C is 18. So a lot of kids do this a really long way. They use law of cosines to figure out angle B, and then once you know angle B, you can find the height using trig. There is nothing wrong with doing it this way, but we're going to use Heron's formula. I'm going to show you a shortcut. So first, find the area. So first I need the semi-perimeter, which is going to be 24 plus 14 plus 18 divided by 2. 24 plus 14 plus 18 divided by 2 is 28. And then the area will be 28 times 28 minus 18, 28 minus 14, and 28 minus 24. And that comes out to be 125.22. So how does that help us? Well, now, a little bit tricky. Step 2, if you know the area, and you know the area is 1/2 base times height, then you can use your easily found area and your known base. Oh, I was going to write base, B, but I'm going to write out the word base because it's not the letter B, times 24, and that's an easier way to get the height. So you can either multiply by 2 first, or you can simplify that to 12, might be a little safer way, and then divide by 12. And you get 10.435. But they did ask you to round to the nearest foot, and it just barely does not round to 11, so it is just 10 feet. So remember, it's not that you have to do it this way. You could use law of cosines to find B, and then trig to find H, and there's nothing wrong with that. Just giving you guys some options. Number 8, a city block is triangular in shape. The frontage along High Street is 423 feet. That along Conover Street is 700, clearly I did not draw this to scale, feet. And that along First Street is 524. A developer wishes to find the area of the plot. What is the area? So whenever you have 3 sides, Heron's formula is definitely the way to go. K is equal to the square root of, and the first thing I need is S. So again, how do I find S? I'm going to do 524 plus 764 plus 423 all over, again, not 3. It's really easy to accidentally do that, but it's over 2. It's just the semi-perimeter, not the average. And divided by 2 is 855.5. Okay, so this right now is on my calculator. So if you want, you can use the store button and store it as X. And then I literally would type into my calculator, instead of doing 855.5 times 855, I would just do X. X times X minus 524 times X minus 423 times X minus 764. It's a great use of your store feature. And then you don't have to keep typing this in, because even just one missed digit and you'll get it wrong. And I already have the answer up there. But again, it is 105,938.9 square feet. Okay, number 9, last one. In a softball game, a batter hits the ball to center field. The center fielder then throws the ball to third base. The distance from the center fielder to home plate is 240 feet, and the distance between the bases, like in the problem we did earlier, is 60 feet. How far did the center fielder throw the ball? So I'm going to be a little tricky again and make my baseball diamond. That was kind of handy to have that. And again, these are 60 feet, but the center fielder is way out there. I'm not drawing this to scale because I don't want to go into my words there. But this distance is going to be 240 feet. And they want to know how far he threw the ball. So X. Like last time, the key to this problem, even though it's not stated, is that since this is a baseball diamond, if he's directly in line, then this would be a 45-degree angle. So again, I can set this up as law of cosines. I guess maybe I'll change this to A. So this can be A, and this can be B, and this can be C. And let me just mark out that triangle a little bit better. The triangle that I'm working with is this one, where this is A, which is what we're going to be looking for. So A squared is equal to C squared, 240 squared, plus B squared, 60 squared, the order doesn't matter, minus 2 times 240 times 60 times cosine of 45. So again, if you get this number on your calculator, 40,835.3247 for A squared, then when you want to get A, if you really want to not have to type that whole number in again, then you can hit the square root button and then the answer button, or you can just start to type to the 1/2, and when you do the caret, it is automatically going to insert answer for you, and it'll do answer to the 1/2. And either way, you're going to get 202.078 feet. All right, that is it for section 6.2. Have a great day.